This is our video for Thursday, April 30th. Our objective today is to talk about summation notation. You should have your books open to page 560. So just to review, on Monday we had our introduction to sequences. Tuesday we talked about explicit formulas and how to find them. Wednesday we talked about factorials, and today we're going to talk about summation notation, and tomorrow we'll have a quiz on section 8.1. Now, the first thing you should know is that summation notation is also referred to as sigma notation, and I will probably refer to it as both as we go through this video. And both terms are correct. Summation notation uses the Greek letter sigma, and that's why some books call it sigma notation. And when you see this Greek letter sigma, it means that you need to sum some things up. S-U-M. You need to add them together. And so that's why both terms are accurate. And so what we're going to do is we're going to take the terms of a sequence and add them together. Add them together. And that's why it's in this section. Remember that a sequence is just a numbers in a very specific order. There's a reason why they are together. So let's talk about the notation, and then I'll give you an example. And so you're going to have the Greek letter sigma. You're going to have, I'm just going to start with an I because that's what they did in the blue box on page 560. This can be any lowercase letter. And this lowercase letter is called the index of summation. And we're usually going to use N, but it could be any letter. And it's going to be equal to a number. I was going to put 1 there. And that is called the lower limit. And there will be a number up here. I was going to say N. And this is the upper limit. And then there's going to be an explicit formula right here. So the A sub I will be an explicit formula for the sequence. And what we're going to do is we're going to take the first term and we're going to add it to the second term and add it to the third term. And you keep finding terms and adding them together until you get to the nth term. And so you're going to start with whatever term they have down here as your lower limit, and you're going to find all of the terms from that term to the term number on the top and add them together. So let's look at an example. If I have the sigma and I want to start, I'm going to use N as my index of summation. I'm going to start with the number 1, and I'm going to go to 6. And my formula is 3 to the n. So the explicit formula is I'm taking the term number and multiplying it by 3. I'm going to start with the first term all the way to the 6th term and add them together. So I'm going to take the first term would be 3 times 1. Second term is 3 times 2. Third term, 3 times 3. The fourth, the fifth, and the 6th. And I'm going to stop. So I started at 1. Went through all of the term numbers until I got to 6. So my first term is 3, second is 6, 9, 12, 15, and 18. And I would add all of that up and get 63. So summation notation, sigma notation, you're going to find the terms of your sequence and you're going to add them together. And we use this notation in calculus. For something called a Riemann sum. And again, you just start with this term and go to this term and add them together. Another example, if we had R is equal to 3 and 8 is our upper limit, and we have negative R. So again, they can use any letter they want, and they can start with any term they want. This one wants us to start with the third term. So the third term, I'm just going to put in 3 for R, and so that would be negative 3. And my next would be negative 4, and then negative 5, -6, -7, -8. So I stop at this term, and when I add all those together, I have -33. So just start with this term, plug in, find each term until you get to the upper limit, and then you will add those together. Summation notation. All right, so let's turn to page 564. And let's talk about the directions for 75 through 86, say to find the sum. And so if we look at number 77, we have our sigma notation. We're using K, and we're going to start at 1 and go to 4, and they just have a 10. That's kind of strange. So all of our terms are 10. So this would be my first term, my second, my third, and my fourth. And 10 plus 10 plus 10 plus 10 is 40. Okay. All right, so I just kind of wanted to show you that one. Now, what I really want to look at is on the next page. If you look at 91 through 100, it says use sigma notation to write the sum, then use a graphing utility to find the sum. Okay, we're not going to do the graphing utility part, but they're giving us the sum, or the sigma notation, or excuse me, the summation notation, and they want us to turn it back into our sigma notation. So they always like us to be able to go backwards and forwards. So they're giving us this part, and they want us to turn it back into sigma notation. So I'm just going to go ahead and put my notation here. And it looks like we got 1, 2, 3 to 9. I'm going to use n. So they started with 1 and went to 9. And all of the numerators are 1. And then it looks like they just multiplied 3 by the term number. And so this sigma notation should result in this summation. And so I'm going to give you a few of those for you to work today. All right. So remember that tomorrow we're going to have our quiz over 8.1. Zoom is at 10 o'clock if you have any questions. And at 10:30 I will open the quiz. Your work for today is on page 564. I want you to work the even 76 through 86, 92, and 94. So the even 76 through 86, 92, 94.